Hey class, today we're going to go over tangent lines. You should all have this worksheet, which was attached to the posting. So we're just going to go over a little bit about it. A tangent line intersects a circle at exactly one point, called the point of tangency. So if this is a circle, this is a point of tangency. If you have a line that intersects that circle at exactly one point, no matter how far the line extends in each way, in each direction, then it's called a tangent line. This is not a tangent line. Not a tangent line. And the reason it's not a tangent line is because if you extend it forever in both directions, it will hit the circle at a second point. So that is not a tangent line. Some people got that wrong on the circle test. This could be a tangent line because it intersects at one point. This could be a tangent line because it intersects at one point. And this could be a tangent line because it only intersects at one point. So just understand how a tangent line looks. Okay, so the next portion of the lesson says a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. Well, let's see how that looks. Here's a circle. Here's a point of tangency. And here's a line that goes, a tangent line that goes through that point of tangency. And what they're saying is that this line is tangent to this circle if and only if it is perpendicular to a radius drawn to that point of tangency. And perpendicular means, remember, 90-degree angle. So problem number 1 asks us to determine if line AB, that's this line right here, is tangent to circle P. This is circle P, we know, because at the center of the circle there's a P. There's some other lines drawn on here, but the bottom line is if this line AB is tangent to this circle, then this is a 90-degree angle. If that's a 90-degree angle, then using the Pythagorean theorem, a squared plus b squared equals c squared. And remember, this is legs squared plus legs squared equals hypotenuse squared. So looking at our diagram, the line that's directly across from the 90-degree angle is 17. That's the hypotenuse. So that goes here. Then this would be one leg and this would be the other. So 8 squared plus 15 squared equals 17 squared. Let's see if that works. 64 plus, I believe that's 225 equals 17 squared, which is 289. Let's see if that works. 64 plus 225, 289 equals 289. So, since the hypotenuse squared equals the leg squared plus the other leg squared, this must be a 90-degree angle, which proves that this line is tangent to the circle because it is indeed perpendicular to that radius. Now, problem number 2 says determine if AB is tangent to circle P. If it is, this would have to be a right angle, and a squared, which would be one leg squared plus the other leg squared, b squared, would have to equal c squared. Let's see if it does. But the only problem is this piece is 5. We don't know what this piece is. Oh, it's a radius. So it's got to be the same as this radius.